Hello and welcome to Lesson 2 of Module 7. Today we are continuing with the same standard that we worked on yesterday, 8NS1, all about rational and irrational numbers. Today's objective is that by the end of this lesson you'll be able to find the square root of numbers that are represented within radical signs. You'll know you're successful when you can find the square root of numbers that have perfect squares and those that do not. So we practiced a little bit yesterday, but we're going to really get into it today. One thing I do want to point out too is a couple of vocabulary words. So you see this picture down below. This N on the outside, this is called our index. And if it's blank, then it just means that it's automatically a 2. It's an invisible 2. But sometimes there's a 3 there or a 4. And that means that you're finding the cubed root of something or the fourth root, I don't know how to really say it, of something. So the number inside of this radical symbol is called your radicand. And then obviously this little symbol, this is called your radical symbol. So just keep in mind those words as we go through and might be using them throughout, okay? Let's get started. All right, on this slide, we are just going to fill these in, and I want you to do this on your paper as well. Don't just listen. Please write what I write. So 1 squared is the same thing as 1 times 1, and this equals 1. 2 squared is the same as 2 times 2. This equals 4. 3 squared is the same thing as saying 3 times 3, which is 9. 4 squared is 4 times 4, 16. 5 squared is 5 times 5, which is 25. 6 squared is 6 times 6, which is 36. 7 squared is 7 times 7, which is 49. 8 squared is 8 times 8, which is 64. 9 squared is 9 times 9, which is 81. And 10 squared is 10 times 10, which is 100. So these are perfect squares that we should know by now. You should be familiar with most of these. Sometimes you might need to do the math out on some of them. But for the most part, you should know what each of these numbers squared means. So you learn like your multiplication in 3rd and 4th grade. In 8th grade, you should really have these numbers down. You should be fluent with these expansions when it comes to exponents, okay? Now on the right side, this is where we get into a little bit of new learning. But it's pretty easy if you know the left side. So if you know this side over here, this side over here is going to be easy. So the square root of 2. So what times what equals 2? Well, you know what? We don't have that number over here. So if you look at these numbers, it is not there. We don't know what the square root of 2 is. This is going to be a decimal. But I do know that it's going to be in between these two numbers, 1 and 4. So it's going to be between 1 and 2. So we kind of talked about that a little bit yesterday. We're going to get into this a little bit more today. I just want to include that as our first one. But the rest, these are perfect squares. This is square root of, the square root of 4 is 2. 2 times 2 equals 4. So if we're taking the square root of that, it is 2. Square root of 9 was 3. 16, 4. 25, 5, 36 is 6, 49 is 7, 64 is 8, 81 is 9, and 100 is 10. So remember, the square root is the opposite of squaring. Just like we have addition and subtraction, we have multiplication and division, we now have squaring and square rooting. Okay, these are the opposite. Okay? They undo one another, and we just want to really get familiar and fluent with these perfect roots. So these are all perfect roots. The only imperfect root that I showed you was that top one, square root of 2. It didn't work out, right? Make sure you have this down. It'll really help us in our lesson today as we move forward. You can go back and reference this page if you need to. But I'll give you a second to do that. And again, we call these perfect square roots. All right, moving forward. Okay, so for example 1, we're just going to go through these and answer them. So it says, determine the positive square root of 81 if it exists. explain. So sometimes we're not going to have a positive square root of something. It's not going to be perfect, etc. So we just have to really think through it. So if I think about 81, and I think about two numbers that make this up, what times what equals 81? Well, I know that 9 times 9 equals 81. So the square root of 81 is 9. And to explain this, I would just show my work, which is right here. 9 times 9 equals 81. 9 squared equals 81. All right? Now we're going to move into numbers that are a little bit more difficult because we might not have them memorized. So we have 225. And I'm going to try to find out what two numbers make this up. Well, I'm going to do some guessing and checking. So I'm always going to start with probably 10 or 11 or 12 because those are my biggest ones that I have memorized. So I know that 12 times 12 or 12 squared is 144. And I'm trying to get bigger than that. I'm trying to get to 225. So I'm just going to keep going up. 13 times 13. Do it in my calculator. I get 169. Okay. 14 times 14. I get 196. So we're getting closer. 15 times 15. That's the one. I get 225. So 15 times 15, or 15 squared, is 225. So the square root of 225 is 15. It's a perfect square. And my work, right there. That's my explanation. All right, moving on to the next one. This is where it gets a little bit trickier, but not super tricky, okay? So we have negative 36, and we're trying to figure out what two numbers, when multiplied together, make up negative 36. Well, you might be thinking, well, I know 6 times 6 equals 36, right? So maybe it's 6 squared, but that doesn't make up a negative 36. That makes a positive 36, right? So you say, okay, well, why don't we just make one of these a negative? Well, we can't do that because then that's not squaring the same number. These are now different numbers. Okay? So that wouldn't work. And you say, well, why don't we make both of them a negative? Well, if we do negative times a negative, that makes a positive. So, does there exist a positive square root for this number? No. No positive square root exists. And the reason being is that we're never going to be able to square a number to get a negative number. So this does not equal negative 36. It equals positive 36. So this is kind of our work right here. And hopefully that makes sense to you, right? Okay, moving on to the last one at the bottom here. We have 49. Trying to figure out what times what equals 49. Well, you should know, based on just like your multiplication facts that you've been practicing for forever, that 7 times 7 equals 49. So the answer is that the square root of 49 is 7, because 7 squared equals 49. And here is our work. Okay? So make sure you have this down. This is just going to be our process today. Sometimes we're going to have to do a lot of this kind of work. But sometimes we're going to know our roots because we're really familiar with these numbers, right? Just from our multiplication facts. So make sure you have this down and we're going to move forward. All right, so now we are going to move on to example 2 where we are placing numbers on a number line. So we have the square root of 1, the square root of 4, the square root of 9, and the square root of 16. So first, let's see if we can figure out what these numbers are. What times what equals 1? What times what equals 1? Well, 1 times 1 equals 1. So the square root of this is 1. So this is where this falls right here on my number line. Okay, those equal the same thing. Right, moving on to the square root of 4. What times what equals 4? Well, 2 times 2 equals 4. So this is where the square root of 4 lies. Square root of 4 is the same as 2. Next, we're going to do the square root of 9. Well, square root of 9 is 3, because 3 times 3 equals 9. And lastly, right here, we have the square root of 16. We know that 4 times 4 equals 16. So we can write this above our 4. Square root of 16 is equivalent to 4, because 4 times 4 equals 16. So these are all perfect squares, right? But I want to ask you guys what happens when we don't have perfect squares. So I'm going to add some numbers down below, and we're going to see where they would fall on this number line. Okay? All right, so I've written down some roots over here. I have the square root of 3, the square root of 12, and the square root of 1/2. And we're going to determine where on this number line would they fall. Now, I can already tell you these are not perfect square roots. Okay? Nothing times nothing equals 3. That's a whole number. Nothing times itself equals 12. That's a whole number. And nothing times itself equals 1/2. That's a whole number. So we're not going to be able to figure out the exact placement, but we can figure out where they lie between on our number line. We can kind of estimate. So that's what we're going to do. Okay? So for this first one, for the square root of 3, I know that I don't know what makes that up. I don't know what squared equals 3, but I do know that the square root of 3 is in between a couple of perfect squares. Square root of 4 and the square root of 1. Okay, because 1 times 1 is 1. 2 times 2 is 4. So I'm trying to get what times what equals 3. It's going to be somewhere in between here. So the answer is going to be between 1 and 2. It's going to be a decimal between there. That's where I can estimate that this goes on this number line, okay? For the square root of 12, well, I know that there's a few perfect squares. We have 3 times 3, this is 9. 4 times 4 is 16, so it's going to be in between those two numbers. So it's going to be somewhere in between 3 and 4. Okay. And then I have this last one, 1/2. So 1/2, what's 0 times 0? 0. What's 1 times 1? 1. So it's directly in between those two things. So this is going to be right over here in between the 0 and 1. So even when we can't find the perfect square mathematically, we can estimate where it would fall on a number line and what two numbers it's going to be in between. Okay, so we're going to do this today as well. Make sure you have this down before we move on to the next slide. All right, we're going to go ahead and get into our last example here. It says determine the positive square root of the number given. If the number is not a perfect square, determine the integer to which the square root would be closest. So we're looking to what number does this come closest to? So we have 169. So I'm thinking, what times itself equals 169? Okay, and I'm going to start with my guess and check method. So I'm going to start, like I said, if I have a really high number like that, I start usually with 12 times 12, because I know that one. 12 times 12 is 144. Okay, and then I'll just move on from there. 13 times 13. Well, if I did that in my calculator, I found it. 13 times 13 is 169. So the answer here is 13. Okay. It's a perfect square. Number 2. I'm going to start with probably 13 now because this one's pretty high. I'm just going to keep building. So I'm going to start with 14 times 14. And I got 196, so I need to go a little bit higher than that. 15 times 15. 15 squared. This is 225. So we're getting really close. So now we're just going to try 16 times 16. I got it, 256. So it was a perfect square. So 16 squared equals 256. So that means my answer is 16. It was another perfect square. All right, moving on. We have one below. This one is one we know by heart, or should. 81. What times what equals 81? Well, 9 squared equals 81. 9 times 9 equals 81, so my answer is 9. That's the perfect square root. Okay. Moving down below to 147. What squared equals 147? Well, if I look at the list that I've already created over here, I can see I never hit 147, and I have a number before it, and I have a number after it. So I know it's in between 12 and 13. Which one is it closest to? Well, I think that it's closest to 144, right? It's 147. It's only 3 numbers off. So I'm going to say that this is not a perfect square. And it is closest to 12. Okay, it's closest to 144 root. All right, moving on to the one below. It has the square root of 8. So we're trying to figure out what times what squared equals 8. Well, got to kind of work backwards here. I know that 2 squared is 4. 3 squared is 9. So it's in between these two, 4 and 9. Which one is it closer to? I would say 8 is closer to 9 than it is to 4. So this is not a perfect square. But it's closest to the square root of 9, which is 3. Okay. Last question, number 6 says, which of the problems in number 1 through 5 are not perfect squares? So 4 and 5 are not perfect squares. And it says to explain. So the explanation here is basically no whole number squared will equal the number inside the radical. Okay, no whole number is going to do it. It's going to be a decimal, but we can estimate where it's closest to. Right, and that's what we did when it told us to do that. Okay, go ahead and make sure you have this work down. We're going to move into our exercises and our practice right after we do our lesson wrap up of our new learning real quick. All right, our new learning for today, we were just taking numbers that were in square root format and figuring out the answer to them. So for example, this first one that I have up here, square root of 49. What times what equals 49? What squared equals 49? Well, we know 7 squared equals 49, right? So this would be our answer. Our answer would be 7. The square root of 60, that's one that is not a perfect square, so it's not perfect. Okay? So we could estimate what it falls in between, but we would need to figure out what number comes after it. So I have that one below. The square root of 64, what times what equals 64? Well, we know 8 squared equals 64. And this is a perfect root as well. Perfect square root as well. And so we know that this one in the middle was not a perfect square root, but we know it's closest to 8, right? 60 is really close to 64. It's close to 49, but it's closer to 64. So our answer, we could estimate that it's close to 8. Okay, that's our new learning for today. We're going to move on to our exercises, and then we will get into our exit ticket. All right, here are your exercises for today. I want you to go through and figure out what the answer is for these problems. Okay, tell me what times what squared equals these numbers. All of them are not going to be perfect squares. So if it's not a perfect square, you need to tell me what is it closest to. Okay? Take about 3 minutes to do this. I'm going to send you to breakout groups to practice and come up with some answers, okay? All right, coming back. For number 5, should have been pretty simple for you. You should have determined that 7 times 7 is 49. So my answer for this is 7, and it's a perfect square. For 62, you should have identified that, well, there's no perfect square that equals 62, right? We have 7 times 7 is 49. 8 times 8 is 64. So it's in between 7 and 8. It's closest to 8. All right. And that's our answer right here. For number 7, should have identified that, again, this is not a perfect square. We can start with 11 times 11 is 121. 12 times 12 is 144. We never hit 122. So we don't know the perfect square for this, but it's closest to 11, right? 11 times 11 is 121, which is pretty close to 122. So that's our answer here. Number 8, we have 400. So we know that 10 times 10 is 100. So let's try 15 times 15. Well, that's 225. So we need to get bigger than that. Let's try 20 times 20. And that is 400. So you should have found that this is a perfect square. It's 20 times 20. So our answer here is the square root of 400 equals 20. Last question asks you which of the numbers in exercises 5 through 8 are not perfect squares. Number 6 and 7 were not perfect. No whole number squared was equal to the number inside the radical. All right, make sure you have this down. We're going to move forward. All right, just to close out our lesson, to find the square root of a number, it's shown inside of a radical symbol. When a number is inside of a radical symbol, the question we are being asked is what squared equals this number? So what squared equals 100? Or what times itself equals 100? Obviously, we know that 10 times 10 equals 100. But sometimes numbers do not have perfect squares, which means it's not going to work out like that. But we can approximate our answers. We can figure out what they fall between. So, for example, I have square root of 45 here. Well, I know that 6 equals the square root of 36. 7 equals the square root of 49. So this square root of 45 is going to fall in between, and it's going to be closer to this number 7, because 49 is closer to 45 than 36. So it's going to be right around here. Okay? And it'll be a decimal, but we're not finding that decimal just yet. We're just estimating where it's going to be at today. So that is our lesson closure. We're going to move into our exit ticket now. All right, for your exit ticket, you have quite a few questions, so I'm going to go over them with you right now. It says, write the positive square root of a number x in symbolic notation. So I'm going to do this one for you. So if we were finding the square root of x, this is how we would write it. That's our symbolic notation. Okay. Number 2, determine the square root of 196. So I want you to figure out, what does the square root of 196 equal? Okay, that'll be your answer there. Number 3, the positive square root of 50 is not an integer. It's not a whole number. Which whole number does the value of square root of 50 lie closest to? So I want you to tell me. It tells you this is not a perfect square. But what is it closest to? What is our answer closest to? So think of perfect squares that are close to 50. Okay? And then number 4, you're going to place these numbers on the number line. So you're going to place the square root of 16 on the number line somewhere. You're going to place the square root of 9 somewhere on the number line. You're going to place the square root of 11 somewhere on this number line. It's not going to be perfect, but you got to figure out where it's going to be between. And the number 3.5, I'm just going to do this one for you. 3.5 is directly in between 3 and 4. Okay, so I already did this whole number for you. You need to place your radicals. And that's your exit ticket. Take your time, show your work, do your best. When you're done, there is a lesson reflection for you to do in Google Classroom.